Let's dive into filter. In filter, your task is going to be to take a bitmap image and apply some number of different filters to that image. You'll apply a filter to take an image and convert it into grayscale, making it black and white. You'll take the image and apply a filter to turn it into sepia, giving everything a reddish-brown, old-time feel to it. You'll take the image and reflect it, getting the mirror image of the original picture. And finally, you'll apply a blur filter that will take the image and soften it so the details are a little bit less clear. So these are the four parts of this project: grayscale, sepia, reflect, and blur. But how do you go about applying filters to images at all? Well, every image, remember, is just a sequence of individual pixels arranged into a particular grid. And how do we represent a pixel? Well, on a computer screen, every pixel has three values, which we might call channels: a red channel, a green channel, and a blue channel, where those values range from 0, meaning none, to 255, meaning the maximum. If we set the red value to a small value, you'll see that we have a little bit of red in the pixel. A higher red value means more red in the pixel. And 255 means we have as much red as we possibly can in this particular pixel. We set it back to 0, and the pixel goes back to black. Why is it that each channel value goes from 0 to 255? Well, 0, represented in binary, is just 0, as you might imagine. And 255, represented in binary, is 8 ones, which means that for each color value, we can use 1 byte, or 8 bits, for each color: red, green, and blue. And since we have 3 of those, we can use 3 bytes, or 24 bits, per pixel. So if you've ever heard the term 24-bit color, that's what this is referring to. So we can use the red channel to control how much red is in this pixel. We can use the green channel to control how much green is in the pixel. And we can use the blue channel to control how much blue is in the pixel. But of course, we don't need to just use one of the channels at a time. We can use them in combination to create any number of different colors. If we have a lot of red and a little bit of blue, we have a color that looks a little something like this. And if we have a lot of green and a lot of blue, but just a little bit of red, then we get a turquoise color that looks a little something like this. And if we set each of the channel values of red, green, and blue to the maximum value of 255, well, that pixel is just going to be a pure white pixel. If we take enough of these pixels, set them to the right color value, and arrange them in the appropriate order, the result is that we can actually see an image that looks like something by arranging colors in the correct position. So what files do you actually need to work with in this problem? Well, there's bmp.h, which is going to store information about bitmap images. It's going to store some of the structs that you're going to need to deal with in order to complete this assignment. We've also given you filter.c, which is the program you'll run to actually run these filters, which is going to take care of the logic of reading the file from memory, calling a function to apply a filter, and then writing the new image to disk as a brand new file. Helpers.c is the file that actually contains all of the functions that are going to implement each of the filters for this assignment: blur, reflection, sepia, grayscale. Helpers.h is the header file that's going to declare all of the functions that show up in helpers.c, telling you what the return type of the function is and what all of the types of the arguments to the functions are. Finally, we've given you a make file, which when you run make is going to take all of these files and combine them together into an executable that you can run to actually apply these filters to images of your very own. We've completed all of the files except for helpers.c, and that's where you come in. So how are you actually going to write the code to implement these filters? Well, in bmp.h, we've defined a struct for you called RGB triple, which is going to represent a pixel that has a red, green, and blue value. You'll notice that this struct has 3 fields: a field called RGBT blue, representing the amount of blue in the triple, a field called RGBT green, representing the amount of green, and a field called RGBT red, representing the amount of red. Each field stores a byte worth of information, remembering that a byte is really just 8 bits. Your task is going to be to implement the 4 functions in helpers.c: grayscale, sepia, reflect, and blur. Each of these functions takes 3 arguments: an integer called height, an integer called width, and a 2-dimensional array of RGB triples, a 2D array of pixels, where there are height rows and width columns. So your image might look a little something like this: a 2-dimensional array, which has a particular height, which will be an argument to your function, and has a particular width, which will also be an argument. So if we have an image, which is a 2-dimensional array, Image 0 is going to represent the first row of that image. Image 1 represents the second row. Image 2 represents the third row, so on and so forth. How, for example, would you get the last row in the image? Well, if there are height many rows in the image, and we start counting from row 0, then the last row in the image is going to be image height minus 1, for example. So that's how you get a row of the image. But how do you get it a very particular pixel in that image? Well, image 0 is a row of the image, which itself is just an array. So if image 0 is the first row of the image 0, 0 is going to be the first pixel in that first row. Image 0, 1 is the second pixel in the row. Image 0, 2 is the third pixel in the row, so on and so forth. And we can use this notation to access any pixel in the image. Image 2, 3, for example, is the pixel in row 2 and column 3 of this particular image. So if we have a pixel, how do we actually modify the pixel to change its color values? We'll recall that every pixel is really just a struct that has values RGBT red, RGBT green, and RGBT blue. So to access the properties of a struct, we can use dot notation, using image23.rgbtRed to set the red value of the pixel equal to something, and doing the same for the green and the blue values, for example. If we set the red, green, and blue values all to 0, then we're going to turn this pixel black, because black is the color represented by values of 0 for each of red, green, and blue. Your task in each of these functions, grayscale, sepia, reflect, and blur, is going to be to take the image as input, as this two-dimensional array, and modify the two-dimensional array, changing the individual pixels in order to create the effect that you would get by applying one of these filters.